Good day, everyone. In this video, I will be sharing with you some insights about introductory concepts about matrices, its definition, and the basic of the initial operation, the basic operation on matrices, specifically about matrix addition and scalar multiplication. So please stay with me. I um, lead you to discovering different concepts about matrices. So let me share my screen. Okay, so by definition, an M by N matrix is a rectangular array or arrangement of M times N real or complex numbers arranged in M horizontal rows and N vertical columns. Okay, so let us check the definition of the matrices. So we're given an M by N matrix, wherein M represents the number of rows and N represents the number of columns. Say, for instance, in this specific given, the first figure labeled as figure A, okay, this contains M times N elements. So this is an arrangement of numbers. It's either a real number or complex numbers in such a way that these are arranged into a number of rows and a number of columns, okay, for which M represents the number of rows and N represents the number of columns. So that's why it's stated here that it is an arrangement of MN, M times N numbers. So when we multiply the number of rows by the number of columns, so we have M times N elements. So each entry here, labeled as A11, A12, up until A1N, A21, A22, up until A2N. Then for the last row, we have AM1, AM2, up until AMN. So these are the entries, and AMN is referred to as the mnth entry. Okay, pang ilang entry siya, mnth entry, and this will guide us. Okay, so this would mean that this AMN is located at the mth row and the nth column. Okay, so take a look at this element or entry A12. A12 is located at the first row, second column. So this is the notation for that, and this will help us in identifying the location of a certain element or entry. So say A2N here is located at the second row. Okay, this is the first row and this is the second row. So this A2N is located at the second row and the nth column. Ito yung row natin. Then these are the columns. This is the first column. This is the second column, the third, fourth, fifth, up until the nth column. So basically, if we have this random element Aij, so this label would tell us that Aij is located at the ith row and the jth column. So Aij, I represents the row number, ith row, and J represents the column number. The column number. So let us extend that. So if we say, what are the entries in the first row? So we have the entries in the first row are this one. So A11, A12, A13, up until A1N. These are the entries at the first row. Okay, so first row natin. So for the ith row, Okay? Ith row, the entries, okay, let me label this. These are the entries at row 1, first row. Now, at any row, so how do we describe the entries? Okay, so let's represent the number of row as I. So we have A, I1, okay, to be the first entry on the ith row. A, I2 is the second entry at the ith row. Then I3 is the third entry up until A, I, N. Okay, these are the entries at row I. I'm sorry for the penmanship. And then when we look at the entries at the jth column, okay, so these are this is the jth column. So the entries could be, will be on the first row. This is A1J. At the second row, A2J, A3J, okay, up until AMJ. So if this is the ijth column, so the entry here is AM because this is located at the mth row, and then jth column, AMJ. Okay, wait, I'm sorry. Where's that? Let me say for example, okay, um, we have how many matrices here? We're given 6 matrices here, matrix A, matrix B, matrix C, D, E, and F. Okay, so let's consider each matrix. The first matrix contains 2 rows and 1, 2, 3, 3 columns. So we will say that A is, matrix A is an, oh, it's not an. Matrix A has 2 rows. So it is a 2 by, it contains 3 columns. Okay, so 2 by 3 matrix. So this will also give the, this would tell us when we describe the matrix to be 2 by 3, this would imply that the matrix has 2 rows. I'm sorry, and 3 columns. Columns. So matrix A is a 2 by 3 matrix. And when we consider, say, for example, randomly, let's choose an element. Okay? An entry, say 3, is located at the first row, third column. Okay? First row, third column. So we will say that I do not have much space on this. If the entry at A, first row, third column, A1, 3 is 3. Okay, this one. A1, 3 is 3. Then take a look at matrix B this time. A matrix B contains 1, 2. Okay, we have 2 rows and 1, 2, 2 columns. So B is a 2 by 2 matrix. 2 by 2 matrix, for which basically the entries here are complex numbers. A plus I, this entry, A plus I, is located at the first row, first column. Okay, then negative 3 here is located at the second row, second column. Second row, and then second column. So say if I have B, 2, 2, okay, to denote, so B na lang ginamit ko kasi nasa matrix B tayo. B22, okay, second row, second column. So B22 is negative 3. Then consider matrix C. Matrix C has 3 rows and 1 column. Okay, 3 rows and 1 column, and it's possible for a matrix to have just 1 column like this one, and it's also possible for a matrix to have just 1 row. Okay, so if a matrix has only 1 row or 1 column like this one, it is referred to as a column matrix. But we will have a separate discussion about it. Okay, then consider matrix D. Matrix D has 1, 2, 3 rows and 1, 2, 3 columns. So matrix D is a 3 by 3 matrix. Okay? For which, okay, if we will select this element, say D, okay, 3 is located, this 3 specific location of this entry, okay, 3 is located at the third row, first column. So D31 is equal to 3. Okay? And then how about this one? So the entry located at the second row, third column is 1. So D21 is equal to 1. Second row, and then, oh, third column, I'm sorry. So second row, third column, D23 is equal to 1. And then matrix E has only one element, okay, 3, or 1 and 3. So it's a 1 by 1 matrix. There's only 1 row and 1 column. And then F has only 1 row but 3 columns. Okay, so this is also referred to as row matrix. This one is a column matrix. It will only have C has only 1 column, while F has only 1 row. Okay, so this is a column matrix. Let me note that. This is a column matrix. And this one is a row matrix. Kasi isang row lang. So that's a row matrix. And then, okay, these are some of the observations or descriptions of this given matrices. Okay, but another observation is that, so since we're given different matrices here, matrices of different number of rows and different number of columns, I would like to point out, class, that there is no specific number of rows and no specific number of columns for which we can form a matrix. Okay, we can form a matrix containing the same number of rows and the same number of columns, like a matrix B and matrix D. So matrix B is a 2 by 2 matrix. The row number is the same. The number of rows is the same as the number of columns. Matrix D is a 3 by 3 matrix. Okay, it contains 3 rows and 3 columns. Okay, so equal yung number of rows tsaka sa number of columns. So actually, a special number, a special name for that is a square matrix. Okay, these are square matrices. But it doesn't follow na kailangan ay pareho yung number of rows at yung number of columns. Pwede rin naman kasi na mayroon tayong matrices na magkaiba yung number of rows. But like this one, like matrices A, C, E, and F. Okay, next. Next definition, 2M by N matrices, okay, A with entries Aij and B with entries Bij are equal if they agree entry by entry. That is, if Aij is equal to Bij for all I from 1 to M and J from 1 to N. So this simply means that two matrices are equal if their corresponding entries or corresponding elements are equal. So basically, you can say na kailangan they have the same number of rows and the same number of columns, and the entries, the corresponding entries should be the same. Say, for example, here. So if we're given matrices A and B, and we assume that these two matrices are equal. So if A, matrix A with entries A, I, J, okay, is equal to B with 8 entries B, I, J. So, pag ganito yung notation, this represents a matrix. Or for others, ilalagay, if matrix A is equal to matrix B, then that's fine. So, if these two matrices are equal, then the corresponding entries are equal. So, the entry in the first row, first column, 1, you should be equal to 1. So 2, okay, the entry in the first row, second column of A should be the same as the entry in the first row, second column of B. Okay, if the entry in the first row, third column of A should be equal to the entry in the first row, third column, first row, third column should be equal to the entry in the first row, third column. So in this case, these should be, these two matrices are equal if -1 is equal to W. W is a variable, but we can deduce now that W is equal to -1. Next, so the entry in the second row, let us now examine. So 2, that's correct. Then -3 should be equal to x. -3 should be equal to x. Okay, now we are now getting the specific values of the variables so that the statement matrix A is equal to matrix B. Now, second row, third column, 4, that's correct. Now we are heading to the third row. First column, 0 is equal to y. So 0 is equal to y. So, variable yung y, pero magiging true lang na equal si A and si matrix A at matrix B if y is equal to 0. Next, third row, second column, we have -4 is equal to -4, and that is correct. And third row, third column, 5 is equal to z. So 5 is equal to z. So matrices A and B are equal in this specific example if W is equal to -1, X is equal to -3, Y is equal to 0, and Z is equal to 5. So ang point lang dito is that these two matrices are equal if their corresponding entries, yung entry by entry, dapat equal yon. Yun yung idea natin for equal matrices. Next definition. Oops. If two matrices A and B are both M by N matrices, then the sum A plus B is also an M by N matrix C. We will form another matrix defined by Cij is equal to Aij plus Bij, for I is equal to 1 to M and J is equal to 1 to N. So this simply says that, okay, observe pala natin. Matrix A and matrix B are both M by N matrices. So this means that they have the same number of rows and the same number of columns. Okay. Then, if two matrices have the same number of rows and the same number of columns, then it's possible for us to get their sum. Then the sum is another matrix. We will form another matrix, but that matrix will contain the same number of rows and the same number of columns. And an entry in this new matrix is given by adding the corresponding entries of matrices A and B. Okay, so how's that? Say, for example, if we have matrix A to have entries 3, -1, 5, and then 4, -3, 2. And then B to have, this is a 2 by 3. So we have 0, 1/2, -3, then 4, 1, -6. Now, if we're adding matrix A and matrix B, and if we want to get the sum of these two matrices, it's possible because first, they have the same number of rows and the same number of columns. This is a 2 by 3. This is a 2 by 3. Okay? So, pwede nating i-add. And we are expecting the sum to be a 2 by 3 matrix as well. So, the sum is a 2 by 3 matrix. And how do we get sum? So, this definition tells us that to get the sum, all we need to do is to add the corresponding entries. So that is 3 plus 0, the corresponding entries in the first row, first column. So 3 plus 0, that's 3. The -1 and 1/2, -1 plus 1/2, so that is -1/2. And then we have 5 plus -3, the sum is 2. And then we have 4 plus 4, the sum is 8. And then we have -3 plus 1, -3, and then plus 1, that's -2. And the last entry located at the second row, third column is 2 plus -6. And that will give us -4. So this is how we get the sum of two matrices. But I would like to point out, class, that we can only add matrices if they have the same number of rows and the same number of columns. Pag magkaiba, hindi natin po pwedeng i-add. Say, for example, if we have matrix C to be a 2 by 2, say, for example, -1, 2, 0, 3, we cannot add C to any of these two matrices. Bakit? Ano ang mangyayari? So basically, yung first row, first column, first row, second column, second row, first column, second row, second column, okay, may partner dito. But matrix C has no third column. So ano yung i-add natin corresponding to the third column of matrix A or matrix B? So we cannot do addition if that is the case. So I would like to emphasize that we can only add matrices if they have the same number of rows and the same number of columns. And their sum should be another matrix like this one, containing the same number of rows and the same number of columns. And adding is easy. All we need to do is to add their corresponding. Eh, ganun lang kasimple. I-add lang natin yung corresponding. And I think I have a note on that. Laki ng space ko. Oh, this is another example. So let's have matrices A and B. We will let A to be this 2 by 3 matrix and B to be this 2 by 3 matrix. Then A plus B, okay, we can add this because these two matrices are both 2 by 3. So we're expecting the sum to be a 2 by 3 matrix as well. So sa first row, we have 1 plus 0, that's 1. So we have 2 plus 1, that's 3. And then second row tayo, negative 2 plus second row dito, that's 2. That will give us 0. And then second row, oh, that's second column, I'm sorry. Then second row, second column, negative 1 plus 3 is equal to 2. And then third column tayo ngayon, 3, 3 plus 1 is 4. And then 4 plus negative 4 is equal to 0. So the sum is a 2 by 3 matrix. So I think I place a note here. I will delete some spaces. A remark, it should be noted that the sum of matrices A and B is defined only when A and B have the same number of rows, okay, and the same number of columns. That is only when A and B are of the same size. Okay, so this is the first part of the video. I will be pausing for a while and please watch the second part of the video. Okay.